Thank you, everyone. Good morning, good afternoon, good evening from wherever you joined. This is the Houston Fabric user group. Thank you for joining us today. Today, this topic is exactly not my cup of tea. I'm really excited about it, but this is I'm going to be playing the role of host than anything else today because this is more in the realm of the sequels and whatnot. So, which is really exciting because it opens up Fabric beyond OLAP. So, we in general think about simply the base perspective. Govind, you can pull up the presentation. Think about
Yeah,
the best way you can think about it. Like most of the workloads on our data side, we were split between OLTP and OLAP, and they're going to talk more about it. But think about transaction processing, which was more row level, and analytical processing like Power BI, which is columnar data and things like that. And now, technically, this is like Fabric essentially is getting to a point where you can have both in the same place and try to leverage best of both worlds. And this is the think about, I think Satya said till SQL Server, the biggest thing that came out was Fabric. Now think about you have SQL Server in Fabric, so it makes it even bigger technically. We'll see how this works out, but we're pretty excited about it. And maybe let's dive right into it. I guess quick introduction. My name is Khaled Chaudhary. I'm a principal at Data Crafters. We run the Houston Fabric user group. And without much ado, maybe Chewy, and then we can take the rest of the introduction.
Yep. Chuy Varela, also based in Houston, working data analytics in the last 15 years or so. Happy to be here.
Nicola? He
Yeah,
doesn't need
and
an introduction, by the way, but
I'm Nicola. Come on, guys. I'm Nicola. I'm not based in Houston. I'm based in Salzburg in Austria. So it's an early afternoon here in Austria. And welcome from my side. And yeah, happy to join these guys here for this
we have
hopefully
issued
useful session.
we have issued a temporary residency for Nicola for Houston.
We'll see. We'll see.
Govind?
yeah. Hello, everyone. I'm Govin. I'm based out of India, and for the past 2 years, I've been working on Microsoft Fabric, exploring its nuances. I build data architectures for client, meaning organizations who want to migrate to Microsoft Fabric. I'm excited about discussing SQL database, and yeah, we can jump right into the session, Khaled.
All right, let's take it away.
Okay, so the agenda for today, we're going to cover just four different topics, just in general overview about what having an SQL database in Fabric implies. So we're going to go a little bit on history lane, just remembering what OLTP is versus OLAP. We will explore a little bit on the evolution of Microsoft SQL per se. And then we are going to explore on what SQL database in Fabric means. We're going to cover also some patterns in architecture about data, storage, and modeling, and all that. And we'll close with some QA session at the end. So first, next slide, please. OLTP, what it really is, and it was an aspect that was not available in Fabric until recently, until the end of last year. So having OLTP included in Fabric means that we can have all that small and fast transactions that we normally do in OLTP and include that in Fabric now. So SQL database is just adding that missing piece that we know we always work with on the data analytics space, because I mean, at the end, it's just one report or one cube that we use for analytics, but all that data comes from somewhere, and it's normally a processing system. Let's move on. Next slide. So OLTP and OLAP, the mac and cheese of data analytics. One leads depending on the other, so they mix together and put a solution for us. So what is the OLTP? Just I think if we see it just in a simple way, it's just everything that happens in a fast, fast speed, transactions that we do, for instance, in retail, or when we go to the store, and buy something. So it's just, it stands for, in case we didn't know it before, online transaction processing. And it's just one data that is as we're saying is supposed to handle many small transactions. So some of the key features or the capabilities of OLTP databases, as we were saying, one key word is the transactions. It is capable of handling a workload of many transactions. Real-time processing, not to be confused with real-time intelligence, that will be something else that we can handle in Fabric. But in this case, it's just, if we are buying something online in Amazon or whatever, eBay, that transaction gets reflected right away on the database, on the backend. It can handle concurrent operations. So that means that we have more than one users processing transactions, everybody at the same time. ACID properties, we're going to look at that in the following slides in a little bit more detail. High availability, those servers, if one server processing transactions for some reason is not working, there will be another server that can come up and keep your business still ongoing. Scalability, that's something that, especially on the on-prem environments, we can just scale up, scale out, and it is highly normalized. Everything in one big table, not exactly what Power BI likes a lot, but that was the way processing tables go. Processing databases go. Next, please. And just to provide a bit more examples on what OLTP covers or where we can see it, is basically, banking, healthcare, retail, shopping. It's just everything where we do a lot of transactions at the same time. In the bank industry, processing deposits, when we have withdrawals from our funds, all the transactions that can happen in the bank, many transactions. Retail, of course, similar.
Like a quick question, Chewy. For example, right? So this essentially is, I think these are industries and whatnot, but I think if I am I dumb to say that anytime I have an application, the application's writing back and transacting for those database in the back tends to be OLTP?
Yep. I mean, it's just like everything that happens where we are buying, selling stuff, where we need some speed and accuracy in the transactions. What we see in the Power BI side, or when we look at analytics, that's just like aggregating data. We don't deal with the whole thing. So it's more like the volume of records. That's going to be a key difference between what we are used to.
If I simplify and say that whenever I'm using an application interface, which requires the fastest read and write of a row level context, right? The OLTPs are superior. So essentially that's what it's designed to do. So essentially anytime I'm building application and whatnot, I want an OLTP database that maintains all this fun stuff you call ACID and whatnot, right? I'm guessing you're going to give us a little bit more details on that.
Yes, actually, we have another slide where we pay attention to the main aspect of difference between OLTP and OLAP. OLTP is all about, as you were saying, row level or row context. OLAP is more about the column. But yeah, we will see something about that in one later slide.
Any thoughts, Nicola? You can go to the next slide, Govin.
Okay.
Yeah,
So,
essentially yeah, go ahead, go.
No, I was just going to say, Chewy is going to explain about OLTP and OLAP, and the question that you had asked, Khaled, the application needs a system that is capable of, accepting a lot of transactional rights. That is definitely OLTP is the system that can, scale to those requirements.
Awesome.
Here we can take a quick look on the main differences between OLTP and OLAP. High volume transaction, as we mentioned, for the OLTP. On the other side, for OLAP, it's more about high volume, but for analytics. On the OLTP side, it's a traditional database management. Think about SQL Server, Oracle, all those platforms that we have seen in the market for so long. On the other side, OLAP is more oriented to a data warehouse kind of database, meaning that you don't really deal with all the data that is being generated on the source systems. You just go and pull some specific data, some specific rows, some specific columns, and you don't bring everything. On the OLTP side, everything is normalized. OLAP is denormalized to facilitate slice and dice on the data. On the OLTP side, I think this is one big component to pay attention to. It is optimized for writing, for adding more transactions, for updating transactions, while OLAP is more about it's optimized for reading, to facilitate the usage of BI tools like Power BI or Tableau, you name it. So OLAP, the main objective is be fast for reading. So it's optimized for that. OLTP, it's about point inquiries, and OLAP is more about aggregating. So I think one kind of funny way to differentiate these two, something that maybe we can think about is let's think about kitchens. When we go to a restaurant, OLTP we can say is the McDonald's for databases because it's everything gonna be quick. You order something you're expecting is gonna be fast, and we have many people going to McDonald's. So OLTP fast food. OLAP, it will be the big fancy restaurants where we're gonna order something more specific, one dish that it's gonna take some time to get prepared for you, and of course, it's something that is not gonna be generated as fast. So I think that will be one kind of funny, easy way to differentiate the two.
Just to
I'm sorry.
add a point, Chui, on this, like from one of the organizations that we had interacted with, they had an existing architecture where they tried to build an application on top of OLAP, and they tried to get records on a very granular basis, like just one or two records, and they had performance issues. So what they did was like they took the data from OLAP and loaded into a SQL database, which is good for OLTP, right? And that SQL database acted as a stage system for their external application. So what I'm trying to say is like, as Chui was mentioning, when it says read optimized, it is good for aggregate queries where you do a summarization or average of a particular, integer or floating point column. And when you want to just pick one record out of millions of records, that is where OLAP struggles a little bit compared to OLTP. And the difference comes here where you're running analytical queries on OLAP, but when you want to run point queries, which are like just getting one record out of million records, that is where OLTP is the superhero.
That's another good analogy for this. And going back to Khaled's point a moment ago, I think this is the other big aspect where we can differentiate the two, OLTP versus OLAP. OLTP is about the transactional store. It's raw store. All the emphasis on processing is raw level. OLAP is about the analytical store of the data. So everything is based on column storage. And that's what facilitates BI tools to be efficient for displaying the data that we want to go and play with. I think the other aspect in general, OLTP is more about accuracy, speed, high volume of operations, transactions. And OLAP is about analyzing the historical records, identify trends, identify insights. So they both serve different purposes. And going back to the Fabric umbrella, the OLTP aspect is something that not even Power BI had it considered, because that's why we go and consume data from a source. We get the data in Power Query, we do the remodeling, and then we facilitate the data storage-wise for Power BI. But having the OLTP aspect now available in Fabric, it's going to open more options for our solutions in data. So we will explore a little bit more in the next slides.
Thank you, Chi. I just wanted to add one more point here. So the difference of OLTP and OLAP, the reason why one is better than other in a different scenario, is the way it stores the data for processing. And as you can see here, when you have this OLTP, it stores the data by row. Like every row is stored in a linear fashion. Again, this is much more of a representation. In the backend, they have like a lot of algorithms like binary tree to get the record, and a lot of stuff goes in the backend. But the data itself gets stored in a row store format. But when you compare to OLAP, it stores the data in columnar format. So all the column values are stored in a linear fashion. And when you think about an aggregate query, let's say you want to summarize a particular column, because all the values are just next to each other, you would be able to easily read all of the data in just one go, summarize them, and then give the output back. And if you think about it, the analytical queries where you want to, for example, let's say you want to see the last 1 year sales, so that involves reading all the sales value that had occurred in that particular 1 year, right? So if you think about OLTP, skipping the data to read only the sales value would be difficult. But if you think about OLAP, all of them are just next to each other. You can just read continuously, summarize them, and you can get the output. Any points you want to add, Nicola? I know you love talking about row store and columnar. So anything you want
Yeah,
to add?
you guys covered it perfectly. So just a simple example. Let's say you want to show total sales amount for equipment products category in OLTP scenario. The engine needs to scan everything because data is stored as a sequence of rows. So to be able to check product category, it needs to scan all basically everything that is stored on the disk. Whereas with OLAP, where we have columnar storage, it will scan product category, filter out unnecessary values, and then just pull out sales amount, so it can keep scanning all the columns that are not needed by query. That's the biggest benefit of OLAP for these type of queries.
Thank you, Nico. So moving on. So we are going to talk about Microsoft SQL. Now we had been, giving an overview on how OLTP and OLAP systems normally work, how they store data. Now we are going to just talk about specifically the Microsoft SQL that has been evolved over time. And let's jump into that. So in terms of SQL Server history, so if you think about when actually Microsoft released a SQL software, it was back in 1989, and over time, a lot of features were added, and the major points of interest have been captured here. And if you think about Azure SQL, this was the first instance when Microsoft made cloud version of their SQL software. And after that, multiple features were added, like if you think about the columnar in memory storage, if you want to run some queries that aggregate data in a good fashion, you use that. If you want to scale up in a dynamic manner, you can use elastic pool. Likewise, there were multiple features added, but one major feature that was released back in November 2024 is SQL database in Fabric. And I would say, I would say like Khalid can explain this better, why it is a major feature.
From which perspective?
I told about how it was on-premise, then it moved to cloud, and then after that, uh, it is basically a PaaS system, right? But now when
Yeah,
you think
so
about,
I think about this way, right? The SQL database in Fabric, right? The way you want to think about the biggest shift, obviously, you need to think about this is SaaS, right? And what it means to be SaaS, I think we are all figuring this out, right? One of the parts that if you think about SaaS perspective, you just click it and runs, right? And me and Nicola had a fun discussion about this is questions the roles of DBA, right? So the traditional indexing and all that stuff comes right out of the box, right? You don't have to go figure out index and whatnot. So from that perspective, maybe you finally have an option to get rid of those Microsoft Access databases, right? Give them a SQL database on Fabric, right? Which is secure and scalable database perspective. You get the full burn of it, and then you're not dealing with people's Access database. But that's kind of one perspective of it. But the simple perspective, the total cost of ownership significantly reduces when you have in SaaS because it's much easier to deploy and manage the cost of it, right? If you just purely look at from the cost of Fabric versus Azure SQL will look cheaper, right, compared to Fabric. But the question is when you put everything together, think about the life cycle of data, right? We have to create the data, we ingest the data, transform it, then we model the data and then visualize and all the fun stuff we do. Versus the beauty of Fabric database is that no ETL, right? we have the best of OLTP. Think about SQL Server, one of the best transactional databases out there. We get that, and then Govind and Chewy, and we're going to show you exactly how this creates the analytical layer for you. Zero overhead, zero movement on your side, right? So if you're trying to get real-time data out of your database, you can do that without taking a production system down, right? So from that perspective, that's what exciting to me, meaning that we can build solutions. You can deploy the application and analytics layer in the same place without hampering one another. And that's kind of my 2 cents at this point.
That's true, Khalid. And uh, to show like how we can enable it in tenant settings, we just have a GIF
Nicola, you were
here
about
that
to say something?
Just wanted to mention that basically it's not just about creating automatic indexes and statistics and stuff like that. That's obvious benefit of having something like a database like this. But that was also available and still is available in other products. But I would
Correct.
say the thing is here you don't need to worry about let's say providing access to the resources, because everything is handled through single sign-on. And yeah, as you guys said, you just click here and you have your database up and running. That's, I think, the biggest selling point of SQL database in Fabric compared to other similar products.
There you go. If I have a SQL question, I call Nicola.
Okay, well.
So here we just show how you can enable the SQL database in your Fabric environment if it is not available already. So you can just go to the tenant settings. If you search for SQL, you would have a particular setting called as SQL database preview. And if you click on it, you can enable it and you can click on apply. If you want only specific AD groups to have access, you can use the security groups to do that. And now let me show you like how we actually create that particular SQL database. So in the items, if you search for SQL and you can see the SQL database, I am giving a name as OLTPDB. And if I click on create, that's it. I am getting a complete SQL database that I can use for my OLTP requirements. And it has all the features in regards to security and the T-SQL syntax, all this stuff. You can connect to different systems, external applications that you want to write to or read from OLTP. You can use the different connectors that are available. You can give access to a particular person through the roles. And apart from that, you can also see the performance of that particular database in terms of how much CPU it has consumed, what are all the queries that are running in the background, how much it is consuming, all this usual monitoring stuff. You would be able to do it all right from the Fabric interface. Any point you want to add, Nico, Chui, Khaled?
I think one aspect about 10 years ago, or maybe even 5, but I mean, it depends on what industry a company can be where we work. But I remember those days where we needed to have we need to spin off a new database on-prem, going through internal processing, open a support ticket, assign it to the DBA team, wait for allocation of resources, or maybe we didn't have a server at the time because it was just the purposes that we wanted to do some prototypes and everything. So that was some kind of hassle that we needed to go by, and basically time, and go through some bureaucracy internally by company. So I think the way we can do it now than a SaaS product, of course, is a different environment, but things are going to be like this. Things are quicker and easier, more convenient. So I think that's one aspect that is a complete 180 on how we can do things now for building data solutions.
That is true, Chui. Like it has become much easier for us to just spin up a SQL database. So in terms of architecture, when you consider the SQL database that we create in Fabric, so whenever you create that SQL database, you also have an additional item called as SQL endpoint. So this SQL endpoint is something that allows you to run your OLAP queries on top of it for your Power BI or any reporting purposes for that matter. And if you think about Power BI, you can either connect to the OLTP layer or the OLAP layer. Both are available, but we normally recommend to just connect through OLAP. The reason being, the analytical queries that you run should not have any impact on the OLTP, so that the actual transactional events that are happening happen without any performance issues. Any point you want to add, Nikolai, here?
Not at this point, yep. We can discuss it later further.
Okay. So we told about how there is another SQL endpoint that gets automatically created whenever you create a SQL database, right? So what is the difference between both of them? So the SQL database that you create is a full-fledged OLTP, right? But we want an OLAP endpoint on top of it so that you can run analytical queries, and that is where the SQL endpoint comes in. And this is more of like, if you have worked with Lakehouse SQL endpoint, it is similar. You can use the SQL to create views, stored procedure, all this stuff. But again, the SQL endpoint has a limitation such that you can only do read-only queries on top of it. So the actual SQL database allows you to, insert, modify data according to your requirements on the transaction system. But the SQL endpoint, which is the OLAP layer, that allows only read-only T-SQL. And the main reason for that is, that is something we would be explaining, but this is more for running the OLAP queries. And the SQL database in Fabric, whenever you create, the SQL endpoint gets automatically created. So this particular SQL endpoint is dependent on the SQL database. In terms of interaction with other items, so this is where we know the SQL database that is in Fabric, but how does the other items that we have in Fabric play with SQL database? So if you think about that, the data pipeline and data flow gen 2 can be used to read and write data from SQL database. So this is in addition to data pipeline and data flow gen 2 that can work with warehouse or lakehouse, but the newly introduced SQL DB has complete support for read write through data pipeline and data flow gen 2. But normally, if you think about OLTP system, you wouldn't be using this much, but it has support for that. And the SQL database in Fabric replicates the data such that it is available for running analytical queries through this SQL endpoint. This SQL endpoint can be cross-queried with Fabric Warehouse and Fabric Lakehouse. So the cross-query meaning, let's say you have another lakehouse and warehouse in your system. If you think about medallion architecture, you would definitely have more than one lakehouse or warehouse, right? So in that case, you can use the SQL endpoint to do cross query between warehouse and lakehouse on top of the data that has been replicated from SQL DB. But directly, you cannot do a cross query between SQL DB and warehouse or SQL DB and lakehouse. Any points, Nicola, Khaled, Chui?
I would just emphasize here, so those are two different items, also separate items, which serves different purposes, although they both have SQL in their name. SQL in Fabric, transactional database, where we store the data, where we load the data using pipelines or data flows Gen 2. And you can't combine this data directly with other data that you have in one lake. If you want to combine data from OLTP database in one lake, you need to use SQL endpoint. So what Govin mentioned, cross queries against SQL endpoint. If you want to change the data which is in SQL database in Fabric, you can't do it through the SQL endpoint. So it's a read-only point that basically contains your mirrored data in Delta Parquet format, so it can be combined with other workloads. That's the main distinction between these two, because so far I heard a lot of people have this confusion between those two items. That's my 2 cents here.
One question, I think, Nicola, this is even from I think I completely understand that if you're trying to combine the SQL data from the database with the warehouse or lakehouse, you're using the endpoint because it's in the serverless whatnot, right? But can you combine the data from lakehouse on the other side on the database? Can database cross query?
Through the SQL endpoint, yes, but directly with SQL database, you can't cross query lakehouse and SQL database. That's not possible because
So essentially, the
formats are
SQL
different.
database does not know the existence of the other lakehouses and warehouses. So if you want to have some data that querying running. So it's going to run two separate query to bring the data together. You cannot run it cross query at the same time.
So not two queries. So when you load the data in SQL database, it automatically mirrors it to SQL endpoint. And then you use this SQL endpoint for a single query to combine data with lakehouse or warehouse.
So think about this,
it's,
right? I am hosting some kind of product data in the database, right?
Mhm.
The statuses of those things are stored in some of the lake houses, right?
Mhm.
So I don't have that in there. So when I visualize something on an application, I'm obviously getting the product in, but the status is on a different place, right? And I cannot run one query, do a join in that query itself. I might actually have to do the join on top of the SQL endpoint, but write to the database.
So if you want to query, if you want to read the data, you read it through the SQL endpoint. If you want to change the data in a SQL database, you can't do it like that. So with T-SQL, you can't write the data in SQL database, the data from a lakehouse. For that, you need to use traditional ETL approach like pipeline or data flows Gen 2, connect to a lakehouse and then write data into SQL database. But essentially, why would you do that? Then you will have like two copies of the same data.
No, the part I'm trying to understand, like, I guess more like when I'm transacting, like I have an application, right? The
Yeah.
application will not load the data using pipeline or Gen 2, right? It's gonna directly use SQL to write back and forth from the database, correct?
Mhm.
Okay, so
Yep.
that's kind of the main thing I was trying to clarify. And I think the key over here is the latency, how far behind the SQL endpoint is compared to the actual
Yes.
database, right?
Yes. In my tests at the very beginning, when it was just announced, it was up to 5 minutes.
Okay, so it's not too bad. I mean, so like think about the best in class CDC, right? Like the Moshes one is still a couple of minutes behind because it has to get the data from whatever source system to a destination and whatnot, versus this one is no headache within 5 minutes. I don't think it's a bad deal.
5 minutes
It
is
depends.
yeah, 5 minutes is good enough for most of the use cases, and anything that that you need much more faster, we normally go with the streaming application, right?
Absolutely.
Yeah. So coming to the HTAP, so we had seen OLTP and OLAP. What does this HTAP mean? So it means hybrid transactional analytical processing. Too many words to fit in the mouth, but yeah. So what it actually means is whenever you change a data in OLTP, it automatically synchronizes into OLAP for running analytical queries. And this particular SQL database in Fabric that we have been showing, so it is HTAP, meaning like whenever you update the data in near real time, the data gets synchronized into the one lake in columnar format so that you can run analytical queries and get get the output from there. And this HTAP, I would say it is not something new in Microsoft tools. If you have heard about Azure Cosmos DB, so they had HTAP, and when Fabric introduced mirroring, it was similar. I would say compared to this, it was one step away from HTAP, but now it's a complete HTAP because it's near real time and it gets synchronized completely in uh, within 5 minutes, like Nicola had mentioned. So any point you want to add, anyone?
Good point in chat from Romain. Yes, exactly. SQL Analytics endpoint, not everywhere in Fabric. In warehouse is read write. Exactly. Yeah, that's a good point.
Coming to the differences between the existing system, right? So we have this Fabric SQL DB, and if you think about the Azure SQL database that most of the organizations have been and are still using. So there are few major differences that we wanted to highlight here. So in terms of cost and how you are configuring the system, that itself is a major difference, because in Azure SQL DB you can use the vCore or DTU model to say how performance you require from this particular SQL database. But if you think about Fabric capacity, so you have capacities that start from F2 to F4096, and when you select that, you get particular amount of compute power that is uh, that is structured in CU seconds, and that is a major difference on how it would be normally configured in Azure SQL DB. So the way you're assigning performance, you know, compute performance for particular database, that itself is a major difference. And if you think about Azure SQL DB, so they have the serverless and elastic pools, which means you have the option to do auto scale whenever there are, whenever there is a uh, unpredicted peak load that was there in your SQL database. So the Azure SQL DB automatically scales up to handle those queries. But if you think about Fabric, there is no auto scale option right now. But given that Fabric is getting updated almost every now and then, definitely I guess there would be a roadmap for this. And in terms of how it is authenticated, how people authenticate to the SQL database, so you can use Entra ID and SQL authentication. And if you think about Fabric SQL DB, right now only Entra ID is supported. So now we had seen how SQL database in Fabric is different from Azure SQL database, right? But how do you compare the existing, I would say, like storage that is available in Fabric for performing your queries, like Lakehouse, Warehouse, and KQL database? So here, if you think about the SQL database, we have specifically highlighted it in a different color. The reason being, this is for a different purpose, which is the OLTP. So you would be using this majorly for OLTP purpose, where you build applications that read and write to that particular database. Just like how Chui had explained, you would be running point queries such that it interacts with very less number of rows, like maybe 2 or 3 rows at a time. A particular query would be interacting with 2 or 3 rows at a time, and out 2 or 3 rows out of millions of records, right? So this particular SQL database has been designed to support OLTP queries, but the other storages that you have, the Lakehouse, Warehouse, and KQLDB, these have been designed for analytical purpose, so that you can run your aggregate queries on top of it and use it for reporting purposes. Any points you want to add, Niku?
Nothing specifically. Yeah.
Okay. So coming to performance monitoring, so what are all the features that are present in SQL database in Fabric for performance? So the first thing is, like we had explained, how the Fabric capacity is powering the SQL database in Fabric. So there is automated alerts. So whenever you are hitting the performance threshold, automatically alert is sent, so that you know there is a performance issue and you can accordingly scale up your capacity. So this automated alerts, it is predefined. So there is a predefined threshold, and whenever that threshold is hit, Fabric automatically sends an alert, and you get a performance dashboard where you can see the queries that have been running, how each query has taken a particular amount of time to run. You can see all the statistics that is associated with running queries on using this performance dashboard. And as I said, the query metrics, which is for individual queries, you can see the compute that had been used, how much duration it had run, all the stuff you can see. And in terms of automatic tuning, so this automatic tuning is present in Azure SQL database as well, and it is available in SQL database in Fabric. So automatically, meaning like Microsoft uses in the backend an intelligent algorithm that scans the queries that normally runs and automatically updates the statistics, as well as creates indexes, so that the best performance is gained by the queries that you are running. Moving on, so the backup and restore option. So this is one more significant factor when it comes to OLTP systems, right? So when you have a application, like imagine your retail application that connects with any database, you want to have it backed up continuously, so that in case of any downtime, you can easily retrieve from the backup. And not just that, you want to have a way to restore in a very quick manner so that the application that you have hosted on top of this database does not have any downtime. Has very less downtime, right? So imagine there are multiple retail websites. So if a particular retail website is down because of the database having any issues, automatically the people who are coming to that website would normally go for a different retail website so that they can get the corresponding item that they need. So if you think about your database is consistently down for some reason, the customers who have been using your retail website normally would think always the site is down, so I will just go to its competitor website and get the item that I need, right? So this is where the backup and restore becomes very significant for OLTP applications. So that is where Fabric has multiple options to configure in terms of backup. So every 15 minutes there is a backup that is automatically run by Fabric so that the data is getting backed up. And let's say you have for some reason a downtime or you want to restore the database, you can just select which restore point you want, and then automatically the data will be restored to a new database. And this particular backup is running in a fixed frequency. Right now, they do not have an option to change the frequency, but it's running at 15 minutes. So ideally, it should be good enough. And in terms of geographical replication, so imagine you want your database to be replicated across multiple regions. Right now, it is not supported, but as I said before, as Fabric is getting updated almost on a daily basis, definitely this particular feature would be coming in the near future. And in terms of no long-term backups, what we mean by that is right now the backups have a 7-day retention policy, post which they are purged, and that is where what we mean by no long-term backup is a particular backup is retained just for 7 days. Any points you want to add, anyone?
One
Moving.
question, Corinne.
Yeah.
Architecture-wise, would it be recommended that we keep a separate backup of an SQL database outside of Fabric? I don't know, run once a month or something. Will that be a good decision on architecture? Just for securing the data.
I get your question, Chui. So usually, for databases, they normally take multiple backups and they store it in different locations.
Mhm.
This particular feature in Fabric right now, it stores the backups in the backups are not visible for us, except when you do a restore, where you can select the particular timestamp of the backup that you want to restore. Right now, we don't have an option to get that backup so that we can store it in our own, but that would be a very good option.
And just to mention that backup is not stored in Fabric, it's stored in your Azure storage account. So it's kind of, different a little bit.
On that one, we have a question, and this is out of my book. So, does Fabric Database have an API endpoint for CRUD functionality like using HTTP request?
I know you can query it with GraphQL, so I assume you can use the regular REST APIs as well. I'm not 100% sure, never tried it myself, but I assume you can.
Fabric, in SQL database in Fabric, when you go to the settings, you can see connection strings where you can connect with multiple programming languages like PHP, Go, Java, all this stuff. So ideally, I believe in the backend, HTTP requests are being used for the CRUD operation. We need to check whether they are directly exposed.
Yes, I think guessing I think you have like the SQL database query, right? So I'm guessing that supports. The question is whether you have an API for it or not. Or I don't know how GraphQL works with this. Is it only read side or it takes writer as well? I don't know. I'm not very familiar with GraphQL. So.
GraphQL can read and write in SQL database.
Oh, there you go. So I guess from that perspective, it should.
Let me double check while we are talking, but I'm 99% sure.
That's kind of the beauty of Fabric, right? Because before we had to get one product to do many things. versus Fabric as a platform gives you a lot of things that it specializes in. And now you got all the pieces in one place that you can leverage from one area. Go ahead.
Yeah. So coming to mirroring, so this is something that we had discussed earlier, the HTAP system. So we just wanted to highlight how it actually runs. So when you create the SQL database in Fabric, there is a near real-time operation that is running in the background. It automatically converts the data into Delta Parquet and the SQL endpoint that we had been talking about earlier. So this SQL endpoint reads the data from Delta Parquet that is present in the one lake, and that is how you are, reading the data from SQL database for your analytical operations in near real time using this particular synchronization that runs in the background. We have been seeing uh, like what is the advantage of using Fabric and what are all the different components that make up this SQL database in Fabric, right? Everything looks good, but what are all the things that you can do with that? Khalid, you want to take up this one?
So think about this, right? Like a lot of times right now, like Fabric, we look at it from purely on the analytics perspective, right? Now with Fabric databases, it opens the entire realm of what can we do and things like that. There are like I remember this is a long time back, 5 6 years ago. We needed to update a record in Power BI, right? And they essentially created an Azure app and all kinds of fun stuff, right? And there are products that works on top of Power BI that does write back, but those are essentially used for planning and whatnot. You don't have, I mean, those are great from specific perspective, but when you're trying to build some kind of application type thing and you need the data, like small piece to get the data to the endpoint, right? And need to say, hey, I'll give you a good example. Um, what we are doing is we're running some machine learning algorithms to classify some of the data, and the data classification is done. But again, this is machine learning, it's not accurate. As the people are reviewing it and they need to make changes, how do you do that? Right? Now with Power Apps, what we can do is have the data, read it, just make those changes real time, and Power BI reflects it real time, right? So from that perspective, Power Apps is definitely one use case how you can use to write the data and modify the data, to be honest, right? We try to do this with warehouses. Well, it doesn't work on lake houses to start with because SQL can write to it. For warehouses, you can write to it, but it's not perfect. And Nicola, I mean, I picked up the pet peeve from Nicola is essentially it will let you have as many duplicates of the primary key you want in warehouse. It will not enforce it.
That is true. So the primary keys in warehouse are not enforced. So that is a reason you might want to use SQL DB for your Power Apps.
Does makes my on the planet, Nicola, or off?
No, I mean, I don't know Power Apps, so I can't comment on this.
But no, I'm
Right
talking
back
about the
things.
like writing to
Yeah,
the
so
database.
in terms of supported features, yes, Warehouse supports, let's say, 98% of traditional SQL, T-SQL commands and statements. SQL database in Fabric supports everything. So as you mentioned, one of those things are enforced keys and other constraints that you can enforce. So you can essentially apply and check logic on a database layer, which you can't do with Fabric Warehouse.
Perfect.
The Power Apps requires the table to have a primary key column so that it can update the data. So in Warehouse, we don't have enforced primary key like Khalid had mentioned. And in SQL DB, you have that option to enforce it. And normally you would use Power Apps with OLTP database so that you can have this primary key. So this is a very small demo where we show how you can use the write back functionality with Power Apps. So in Power BI report, you can have Power Apps embedded, and here we update the quantity column for a particular row, and here you can see it got updated automatically. And if you think about this, all of them are happening on top of the Fabric capacity. So single capacity is supporting everything except for Power Apps, and the SQL database, the mirroring, and then the Power BI report, all of them are running in the Fabric platform. So it's more of like a, whenever Microsoft says about Fabric, one thing that they mention about is unified platform, right? So if you think about it, the entire architecture that we saw in the previous slide, except for Power Apps, everything is running in a Fabric capacity. So moving on, similar to Power Apps, you can have your Azure web app that reads and writes data from SQL DB. And like Nicola had mentioned, using GraphQL, you would be using a programming language like C#, .NET, or Java to interact with the SQL database so that you can read and write data for your transactional apps. So we have been discussing about the different features that are available in SQL database in Fabric and how we can use it in different architectures, right? The reason, like we would say the SQL database in Fabric is good enough for most of the cases is you can simply go and create a new database in the same unified platform that we had been mentioning, and it just takes seconds to spin up a SQL database for your needs. Imagine you have a Power Apps that you need to build. You can just create, I mean, not just Power Apps, you have a write back application that you want to create. You can just spin up the SQL database, create the Power BI report, connect the Power Apps to the SQL database, and then put all of them in the Power BI report so that you have the write back functionality. And on top of all of this, you also have the Copilot integration, which means you can, I mean, if you are not technically, technically advanced to write SQL queries, you can still use Copilot to generate the SQL you want and then change it accordingly. Any points you want to add, Khalid, Nicola, Chui?
Nothing made to
Okay.
kind of, I guess one of the statements to wrap up the session, one that I can think of is that, as many people say in the community, Fabric is all about options. You have more than one way to do one specific task, and having the SQL database now part of Fabric, it also adds up to that. So it depends what kind of solution you want to design and develop, and Fabric is going to give you the option to do it in the best way that fits your needs.
That is true, Chui. So moving on, so when you think about the SQL database in Fabric, what are the things to consider if you're going for that? So right now, SQL authentication is not supported, and there is a fixed backup frequency that we had earlier talked about, and the geo backup capability is not available as of today. But if you think about how Fabric is getting updated almost very frequently, so it is likely that all these features would come up someday in the future, and it would be well in terms of the features that are supported right now in Azure SQL DB. And the reason we have this as of today is to emphasize that it is a limitation right now, but it might be removed someday in the future. So with that, we come to the final thoughts. Khalid, Nicola, you want to have closing comments on this?
From my side, just to so that it doesn't look that SQL DB is now one solution to rule everything. If you still prefer to have control over flexibility, you have the options outside of Fabric like Azure SQL DB, like managed instance, or SQL Server on virtual machines. So it depends what you value more. Flexibility versus control. If you need more control, then probably SQL database is not the best choice for you. That's from my side, just like a final thought.
I think just to understand what you're saying, Nicola, I think if you want more control, you want SQL Server on-prem. Then from SQL Server on-prem, SQL Managed Instance, Azure SQL, and Fabric Database, right? The least amount you lose control as it gets more SaaS.
Yes, if you move from on-prem, let's say you decided to move to cloud, but you want like a full SQL Server that you manage on your own with all patches, updates, and everything else, you use SQL Server on virtual machine in Azure. So that's infrastructure as a service. That's the starting point. And then, as you rightly said, as you move on closer to Fabric, you are surrendering control more to Microsoft. And yeah, but you are getting more flexibility, basically, not to worry about those things, about configuration maintenance and so on. So basically, yeah, that's
I
correct.
think we should create a graph, Govin, that kind of goes from SQL on-prem, virtual SQL, then managed services and whatnot, higher control, more.
That is true. I guess
That makes sense.
Totally. I think it's easier than to understand what's the value proposition of having SQL database in Fabric versus some other offering that covers similar workload.
But no, I
that
think
would be a great
Nicola
graph.
mentioned
Yeah.
an amazing point, right? So my perspective, I think, as we don't have less things to do every day, right? So I think that's where people have the challenge with control versus the benefit of SaaS. The key thing to balance is you need to test your key requirements, because if your key requirement doesn't fit Fabric database, then it's not going to work. Maybe you don't need massive control, but you need control on specific things, and that you need to check whether you have, whether it's from the recovery perspective and control of the resource perspective. And because for us, the calculus of the how it costs, the allocation of resource, all of things have to be figured out, right? Um, so that's something that we are all trying to figure out. But I think from the perspective of creating a near real-time analytics solution that uses the same architecture with least headache, Fabric database plays that role very, very well. Right. So I think again, this is in public preview, so that's why I put caution statement on it. But I think this, as it becomes GA and whatnot, I think it will play a key role as we try to understand how this thing fits in from a cost, direct OpEx and overhead perspective, from a total cost of ownership for a solution.
So, as you rightly said, like it is still in public preview, and we are seeing many changes and updates coming to it on a regular basis. Even just before we started with this presentation, in the LinkedIn, I saw that they had released something specific to the KQL database where it supports cross query between lakehouse and warehouse. That is something, like I have to go and read more about to understand. I mean, it would have a possibility that I have to change something in the slides that I showed earlier. So that is that is how frequently the Fabric gets updated. So we are excited about the Fabric SQL database, and we are following up on the updates regularly to know what is being added. So with that, we can move into the Q&A session. So if you have any questions, you can put it in the chat, and we would be happy to answer.
All right. We probably took care of the questions from the Q&A and chat as we were kind of going. So again, thank you everyone for your time. We probably will be doing an in-person session in February in Houston, so you're more than welcome to come to Houston. But I think in March, we're going to come back to virtual again. So the easiest way to keep track of this, I will go ahead and find the meetup link and also the Houston Fabric user group in LinkedIn. So thank you, everyone. And till next time.
Thanks for joining.
Thank you,
See ya.
everyone.
Thank you, everyone.
Have a good day.
Cheers. Bye.
Bye.